This is another example of finding the probability of at least one. This problem states, to reduce laboratory costs, water samples from 6 public school swimming pools are combined for one test for the presence of bacteria. Further testing is only done if the combined sample tests positive. Based on past results, there is a 0.03 probability of finding bacteria in the public swimming area. Find the probability that the combined sample from 6 public swimming areas will reveal the presence of bacteria. Is the probability low enough so that further testing of individual samples is rarely necessary? So over here, we're trying to find the probability of at least one testing positive. So since we're trying to find the probability of at least one, first thing we have to do is find out the probability of the complement, which would be probability of none of them testing positive, meaning that they're all negative. And then we'll go ahead and subtract that result from 1. That will give us the probability of at least 1. Okay, so now in this particular problem, it's saying that there is a probability of 0.03 that the sample will test positive. So if the probability of it testing positive is 0.003, then the probability of it testing negative, that sample testing negative, would be 0.997. Okay, so the probability of a negative test result. So probability of negative result, this would be 0.997. So what I did is I subtracted 0.003 from 1. So now this is the probability of one sample being negative. Now we have 6 public swimming pools. So the probability that all 6 of them are negative. So probability all 6 negative. This would be equal to, this would be 0.997. So that's the first swimming pool testing negative. And then times, now the second swimming pool, the probability of it testing negative would also be 0.997. And then we're going to keep going for the 6 swimming pools. So this would be, so the 6th one will also be 0.997. So in other words, this is 0.997 raised to the 6th power. So let's go ahead and use our calculator to figure out what this is equal to. So 0.997 raised to the 6th power. This gives me 0.98, say 2. So it says round to 3 decimal places. So this is a probability that all 6 swimming pools will have negative test results. So then the probability of at least one positive, probability of at least one positive, this would be equal to 1 minus the probability that they're all negative. So it would be 1 minus 0.982. So let's go ahead and subtract that. This would give us 0.018. So this would be the probability of at least one positive result. So let's go ahead and type that in. Okay, and now it's asking, is the probability low enough so that further testing of the individual samples is rarely necessary? Well, what this is saying, so we have a probability of 0.018. This is really 1.8%. So 1.8% of the time, it will test positive. So that's pretty low. So the probability is quite low. So that further testing of the individual samples is not necessary. So let me take a look at C first. There we go. That's actually part C, answer C.